Good evening to all. Today we are going to see about database management subject. So that is one of the main subject in GATE preparation. So that we will discuss here. So in that database management system, the syllabus of this one is will covered uh, by ER diagram, relational algebra, SQL integrity constraints, normal form, and the last one is file organizations. So these are the topics are covered in DBMS subject. So first let us see about what is meant by database management system and why we are using this database in a real time. Okay, why we are using, what is the use of that? Okay, so what is meant by database? So database is the collection of the data and it's contain the information about one particular enterprise. The database management system consists of the collection of interrelated data and the set of the program to access that data. So the database management system is essentially the collection of interrelated data and set of the program to access this data. This collection of data is called as a database. Okay, the collection of data is called as a database. The primary objective of the database system is to provide the convenient environment to retrieve and store the database informations. The database system support a single user and then multi-user environment. While on one hand, the DBMS permit only one person to access the database at a given the times. On the other hand, the RDBMS allow the many users simultaneously access the database. The main use of this, the primary objective of the database is to provide the convenient environment to retrieve and store the database informations, which means that the DBMS is a program that organizes and maintains the informations, whereas the database applications, the program that let us view, retrieve and update the information stored in a database management system. Okay, and what is meant data? So database is a collection of the data. And what's the data? The data is a collection of distinct small unit of the information. The database is a collection of the data and the single data means the data is collection of distinct small unit of the information. So it can be used in the variety of the forms like text, number, media, bytes, etc. So it can be stored in the piece of the paper or electronics memory, etc. Okay. And DBMS system, that is a database management system, as a software for storing and retrieving the user data while considering the appropriate security measures. So it consists of the group of the program which manipulate the database, which means that it is a program that organize and maintain the information, whereas the database application is the program that let us view, retrieve and update the information stored in a database, DBMS, stored in a DBMS. Okay. And before seeing the example, first let us know what is the application area of the DBMS. Okay. And the typical applications area of the DBMS are the banking, financial services, and airlines, universities, telecommunications, finance, sales, manufacturing, HR management, transport, tourism, um, productions engineering, computerized library systems, automated teller machines, and the computerized part inventory systems. So these are the applications are used in DBMS. Suppose if you are an student, right? So that now we are going to take a student table. Okay. So in that student file store the data of the each student, and next we can take the next table as the course. The course file stores the contains the data on the each course. Okay. And next take the table as a section, and that section stores the information about the section in a particular courses. And next take table as a grade. That grade file stores the grades which students receive in the various sections. Okay. And so these are the applications of the DBMS. And next let us see about the ER model. So before seeing this ER model, first let us know what is the, what is the main purpose of the database systems. The main purpose of the database system is to provide the user with abstract view of the data. So that is, a system hide the certain details of the how the data are stored and maintained. Okay. So that is a view of the data. How to view the data? That is a view of the data. These are the three levels of the data abstractions. There are three levels of the data abstractions. The first one is a physical level. In the physical level, that is it is a lowest level of the abstraction that describe the how the data are actually stored, and the physical level described the complex low-level data structure in details. The first level is a physical level, so that is the lowest level of the abstraction that describe how the data are actually stored, and the physical level describe the complex low-level data structure in details. And the next level is logical level. So that is a logical level. It is next higher level of the abstraction that describe what the data are stored in a database and what the relationships exist among those data. That is the second level. And then the top level, that is a view level, it is the highest level of the abstraction that describes only the part of the entire database. Why we are discussing here? Because we are seeing the ER model. The ER model comes under that view level, so that we can see the view of the data. Okay, so the ER model, that is entity relationship model, is also called as a ER model. That is high level model. That is the view of the data. That view of the data can be divided into three parts. One is a physical level, and then logical level, and then view level. Our ER diagram comes under that view level, that the highest level of the abstraction that describe the only part of the entire database models. Okay, the entity relationship model, that is called as the ER model, that is a high level model. This model is used to define the data elements and relationship for the specified systems, and it can develop the conceptual designs for a database, and it's also developed the very simple and then easy to design the view of the data. In ER modeling, the database structure is portrayed as a diagram is called as a entity relationship diagram, that is called as a ER diagram. Okay, this is the example of the ER diagram. So in that ER diagram, we are taking the student applications, because we are the student, you are the student, right? So that we are taking the student table. So the student is the entity, that is a table name. So table name as the student. In the table having the student name, and then address, ID, and then age. Okay, so these are the attributes are used in that student table. So this is the example of the ER diagram. Okay, so ER diagram, ER model, that is a ER data model, consider the real world consisting of the set of the basic object and called the entities and relationships among these objects. They intended primarily for the database designs process by allowing the specifications of the enterprise skills. This represents the overall logical structures of the database. And so next, let's see the ER diagram. The major activities of this phase is identifying entity, attributes, and their relationships to construct the model using the entity relationship diagrams. When you construct the ER diagram, the three things are used in that ER diagram, that is entity, attributes, and then relationships. That is ER model deploys the three basics notation, that is entity set, relationship set, and then attributes. Okay, when you are using entity, that is represented by the table, and when you are using attribute, that is a column. Okay, when you are using a relationship, that is a line. Okay, so we can express the overall logical structure of the database graphically with the ER diagram. Its components are rectangle represent the entity set, and ellipse represent the attributes, diamond represent the relationship set, the lines linking the attributes to entity set and then entity set to the relationship set. And this is the components of the ER diagrams. The ER diagram can be divided into three parts, that is three components. That is the first one is entity, attributes, and then relations. So these three components are built in the ER diagram. When you are drawing the ER diagram, these three components are built in a ER diagram. Okay, so first let's see about the entity. The entity is a things or object in a real world. That is that is entities may be any object, a class, person, or place. In the ER diagram, entity can be represented as a rectangle. When you are drawing the ER diagram, first we have to put the table name. So that table name, for example, we are taking the student table or employee table or a customer tables, whatever it is. So that table first we are going to take one table that then we are going to give any name to that table, right? So that name as employee here. Okay, look at this diagram. So the first table is employee and the second table is department. Okay, the entity may be any object, class, person, or place. In the ER diagram, the entity can be represented as a rectangle. They consider the organization as an example, the manager, product, employee, department, etc. can be taken as an entity. So entity can be represented by a rectangular box. Okay, the entity is a represented by the rectangular box. So that our first entity is the employee. So that is represented by the one rectangular box. Another entity is the department, and the line is that is what. Look at the previous slides. That is a rectangle representing the entity set. The ellipse represent the attributes. A diamond representing the relationship set, and then the lines linking the attributes to entity set and then entity set to the relationship set. So please keep it in mind. Okay. And next we'll see about the weak entity. Okay. So the weak entity, the entity that depends on the another entity is called as a weak entity. The weak entity does not contain any key attributes of its own. Okay, the weak entity is represented by the rectangular box. Okay, when you are drawing the ER diagram, so you can draw the double rectangle when you are using a weak entity. So when you are using a weak entity, that is represented by the double rectangular box. Okay, and next let us see about the attributes. That is a second components in the ER diagram, ER model. So the attributes. So what is meant by attributes? So entity is represented by the set of the attributes, which means that the attribute is used to describe the properties of the entity. That is entity, and entity is represented by the set of the attribute. which means that the attribute is used to describe the property of the entity. So which is represented by ellipse. Okay, that is oval shape. Okay, here we are going to take a student table. So in that student table, the student is the entity, that is a rectangle, that is defined by the rectangular box. So that is called as an entity. And then in that student table has a student ID, phone number, age, and the name. Okay, so these are the attributes are used in that student table. So next one is the key attributes. Why we are using that key means because we are using the primary key, foreign key. So these are the keys are used in that year diagram. So that we can use the key attributes in that year modeling. So the key attributes is used to represent the main characteristics of the entity. It's represent the primary key. So that is underlined in the ID field name in the student table. The key attributes is used to represented by the ellipse with the text underlined. So look at this diagram. So next let us see about the classes of the attributes. So classes of the attributes. The attributes are classified as simple attribute, composite attribute, derived attribute, single value attribute, and then multi-value attribute. So next let us see about the simple attribute. Okay. Simple. That is simple means simple attribute is the attribute composed of the single component with independent existence, which means that the simple attribute cannot be subdivided. Uh, that is, suppose we are taking any attributes from the main student table. So in that student table having a name, okay. So in that name, for example, or taking the student table, the table has age is one of the attribute of that student table. So age cannot be subdivided. For example, if you are taking a roll number, so that also cannot be subdivided. Okay. Suppose we are taking a composite attribute, that which means that the attribute that composed of the many other attributes is known as a composite attribute. The composite attribute is represented by the ellipse, and those ellipses are connected with an ellipse. Okay, suppose if you are taking, for example, we're taking the, a student table. In that table having a student name, so that name, okay, that name which is composed of the attributes like first name, middle name, and then last name. Suppose we are taking the address attribute, which is composed of the other component like street, city, pin code. So this is how it will be, execute or written. Okay, so when we are using a composite attribute. Okay, next let us see about the derived attribute. derived attribute that can be derived from another attribute is known as the derived attribute. It can be represented by the dashed ellipse. Look at this figures. So the age. So for example, the age attribute can be derived from the date of birth attribute. Look at this date of birth. So the age attribute can be derived from the date of birth attribute. This is called as a derived attributes. Okay. And next, let's see about a single value attribute. Single value attribute is one that hold the single value of the single entity. For example, room number or customer ID. For example, you take any value. Okay, so that value can have the single value attribute can have only one single value that is called as that attributes are called as the atomic attribute. Okay, the person can have only the one social security number. The manufactured part can have only one serial number. Okay, next, the single value attribute is not necessarily simple attribute. Okay, these are the example of the single value attribute. And next, let's see about the multi-value attribute. So multi-value attribute is one that hold the multiple values of the single entity. Okay, for example, the student entity can have a multiple value of the attributes. For in the student have a more than one phone number. So look at this figure. So in that figure shows that multi-value attribute. Okay, the student table, and the student table has one of the phone number, one of the attributes of the phone number. So that phone number is the best example of the multi-value attribute. Okay. Next one is third. I mean, next let us see about third components of ER diagram. So that is a relationship. Relationship is express the association among the several entities. The relationship set is a set of the relationships of the same types, which means that the relationships are association between the entities. Typically, the relationship is indicated by the word connecting the two or more entities. The relationship is used to describe the relation between the entities. Okay, it can be represented by a diamond shape. That is a diamond shape in a ER diagram. Okay, so when you're using a relationship, it can be used some certain constraints. So that is mapping, cardinality, and then participation constraints. So these are the two constraints are used in relationship components in ER diagram. So, okay, the relationship should be classified in the terms of the cardinality, that is one to one, one to many, and many to one, and many to many. So, etc. So, how to find the cardinality? Okay. The collarity is the number of the occurrence in the one entity which are associated to the number of the occurrence in the another. So these are the three basic causality, the degree of the relationship. The one to one, one to many, and many to many. So here, look at this. In this figure shows, student entity. Another one is a teachers, and so that is related by the relationship that is a teach. Okay. Next, the first type of the causality is the one-to-one relationship. The one-to-one is the when only one instant of the entity is associated with the relationship, then it is known as a one-to-one relationship. So one-to-one. So for example, we are going to take two entities named as A and B. So entity, the first entity name is A and then second entity name is B. So finally we are going to take two entity. Okay, that is named as A and B. Entity in A is associated with at most one entity in the B, and an entity in a B is associated with at most one entity in the A. Okay, which means that when only one instance of the entity is associated with the relationship, then it is known as a one-to-one relationship. Here, look at this example. A female can marry to one male and the male can marry to one female. So this is the example of the one-to-one relationship. It can be represented by this symbol. Okay, when you are using a one-to-one, so it can be represented by this symbol. Okay, and this is an example of the one-to-one relationship. And the next, let's see about the one-to-many relationship. Okay, again we are going to take a two entity. It's named as A and B. So entity in the A is associated with any number of the entity in the B. That is a one-to-one. So in a one-to-one, entity in the A is associated with the any number of the entity in a B, and entity in a B, however, can be associated with the most one entity in the A, which means that when the only one instance of the entity on the left and the more than one instance of the entity on the right associate with the relationship, then this is known as a one-to-one relationship. So it can be represented by this symbol, and the example of this one is we are going to take a scientist. Scientist in the one of the entity, another entity is the invention. The scientist can invent the many invention, but the invention is done by only the specific scientist. So this is the example of the one-to-many relationship. So we are going to take two entities, they named as A and B. Entity in A is associated with any number of entity in B, and the entity in B, however, can be associated with at most one entity in the A. Okay, That is the concept of the one-to-many relationship. And next one is many-to-one relationship, which means that when the more than one instance of the entity on the left and the only one instance of the entity on the right associate with the relationship, then it is known as a many to one relationship. So that is indicated by this symbol, and look at this example. The student enrolled for the only one course, but the course can have many students, which means that now we are going to take its entity, that is a two entity set. Entity in A is associated with at most one entity in the B, and entity in the B, however, can associate with any number of the entity in the A. So that is best definitions of the many to one relationship. And next, let us see about the many to many relationship, which means that entity in the A is associated with any number of the entity in the B, and entity in the B is associated with any number of the entity in the A. So which means that when the more than one instance of the entity on the left and the more than one instance of the entity on the right associate with the relationship, then it is called, then it is known as the many to one relationship. So for example, here we are going to take employee table. The employee can assign by the many project, and the project can have a many employees. So look at this figures. So next, let us see about the test. In a year model, we are using a two constraint, right? That is, cardinality and then participation constraints. Okay. Now let us see about the participation constraints. So the participation constraints are indicated by the bold lines in the ear diagram. When you are drawing the ear diagram, so you should draw the double line when you are using the participation constraints. Okay, that is indicating by the bold lines in the ear diagrams. We can use the bold line to indicate the participation constraints when you are drawing the ear diagram. When you are drawing the ear diagram. Okay, and the arrow lines to indicate the key constraints independently of the each other to create the expressive language of the possibilities. So there are two types of the participation constraints. One is total participations, and then second one is partial participations. First, let us see about the total participations. The participations of the entity set E in the relationship set R is said to be a total if every entity in the E participate in at least one relationship in the R. Okay, which means that the total participations is when each entity in the entity set occur in at least one relationship in that relationship set. Okay, So look at this figure. So in that figure, or next one is a partial participation. If only some entities in E participate in a relationship in R, the participations of the entity set E in a relationship R is said to be a partial. Look at this example, look at this figure. So for example, we expect the every loan entity to be related to at least one customer through the borrower relationship. Therefore, the participations of the loan in the relationship set borrower is a total. Okay. Why the bank customer may or may not have a loan. Therefore, the participations of the customer in the borrower relationship is partial. Okay. So look at this figure. This figure shows that as we expect the every loan entity to be related to at least one customer, okay, through the borrower relationship. Okay, therefore, the participations of the loan in the relationship set borrower is the total. That is a total participations. While the bank customer may or may not have a loan. Okay, therefore, the participations of the customer in a borrower relationship is a partial. Okay, so you know the difference. Okay. Okay, so total participations. Each entity is involved in the relationship. That is, each entity is involved in the relationship. The total participation is represented by the double lines. Okay, here we are using a student and then course table. So in that. So the total participation is represented by the double lines. So this is the example of the total participations. When you are drawing the ER diagram, so here we are using a double line. Okay, when you are using a total participations. The partial participation. Not all entries are involved in the relationship. The partial relationship is represented by the single lines. So this is a example of the partial participations. Okay. If we are using a total participation, that is represented by the double lines. Okay. If we are using a partial means, that is represented by the single lines, which means that not all the entries are involved in the relationship. That is the meaning of the partial. If we are using a total means each entity is involved in the relationship. That is called as a total participations. Okay. So next let's see about the questions, that is a gate questions, how they are asking the DBMS questions. Okay. So the first one is this is an example of the questions. Okay. So first one is which of the following is used to represent supporting the many one relationship of the weak entity set in the entity relationship diagram. Okay, so the question is the which of which one of the following is used to represent the supporting many one relationship of the weak entity set in the entity relationship diagram? So this question is asked in 2020 year. So the question, what they are asking? That is, they are asking the relationship. When they are asking the relationship means that is represented by the diamond shape. Okay, so they are asking the relationship and also they are asking the weak entity set. Weak means that is a double. Okay, they are asking the relationship indicating the diamond symbol. So that the answer is the diamond with a double or bold border. Okay, because they are asking the relationship only, not a rectangle. Rectangle means that is an entity and then oval is the attribute. Okay, so diamond indicating the that is relationship and the rectangle indicating entity and then oval indicating the attributes. So please keep it in mind. So when you are drawing the ER diagram, so these are the things are there in the ER modeling. Okay, and the next question is which of the following is a correct attribute set for one of the table for the correct answer to the above questions. This is one question. So in that question, the first entity is the M, and then second entity is the P, and then the final entity is the N. Okay. So the R1, R2 is the relationship, okay, that is represented by the diamond. So the double lines that is represented by the total participation. So, okay, the single lines that is partial participation. So, okay, when you are using double lines that does represented the total participation that does each entity involve the relationship. So that the answer is the first one, M1, M2, M3 and then P1 because they are using a total participation that is indicated by the double lines in this figure. So that the answer is the first one. That is the M1. M1 has M1 is M is the entity. That entity has the M1, M2, M3, and also they using the double lines that is indicating the total participations. So the total participations means so that the P1 will be moves to the M. The answer is the first options that is M1, M2, M3 and then P. And the third questions, consider the following year diagram. The minimum number of the table needed to represent the M, N, P, R1 and R2 is. So the question is, so we need a minimum number of the table. Okay. So how many tables are we used in this figures? Okay, so, that is a question of this that is that is a question of this figure. So in that figure so M1 P and then N is a three entity and R1 R2 is that is a relationship. So that we need a three table minimum we need a three table. So that the option is B. So the B has a 3. Okay. So next let us see about fourth questions in gate preparations. Given the basic year and then the relational model, which of the following is incorrect, not correct? So please listen carefully. So which one is the incorrect? Which of the following is incorrect? So the first option is the attributes of the entity can have a more than one value. The attributes of the entity can be a composite. In a row of the relation table, the attributes can have a more than one value. In a row of the relation table, the attributes can have exactly one value or a null value. The answer is C because the entity belongs to the ER model and the relational table belongs to the relational model. Okay, the entity belongs to the ER model and the relational table belongs to the relational model. So the A and B both are same because the ER model support the both multi-value and the composite attributes. Okay, and then C is false because in a relational model the entity in a relational table can have exactly one value or null values. That is the correct one. So that the C is false. The A, B and then D is a true value and then C is a false value. So that the answer is a C because the relational model, the entity in a relational table can have exactly one value or null. And then the fifth questions, let E1 and then E2 be a two entities in the ER diagram with a simple single value attributes. R1 R2 are two relationships between the E and E2 where the R1 is the one to many and then R2 is a many to many. Okay, and then R1, R2 do not have any attributes of their own. Okay, what is the minimum number of the table is required to represent this situation in the relation model? So once again repeat, let E1 and then E2 be a two entities. So two entity name is E1 and E2 and then the relationship name is R1 and then R2. Okay. So the R1 R2 are two relationship between the E1 and E2 where the R1 is the one to many and then R2 is a many to many and R1, R2 do not have any attributes of their own. Okay, what is the minimum number of the table is required to represent this situation in the relational model? So this is our question. Okay, the answer is B because we need three tables. Okay, then only we can use this question. Okay, and any doubt? So any doubt so far? Okay, once again I repeat. So in a database system, we have to see in a database system, we have to see the ER diagram, relational algebra, SQL integrity constraints for normal form, and then file organization. Now, in this section, we have discussed only the ER diagram. So, in that ER diagram, that can be divided into three sections. One is entity set, attributes, and then the relationship. Okay, when you are drawing the ER diagram, please keep it in mind. We are using three components, that is entity, attributes, and then relationship. Okay. See any doubts so far? Okay, thank you.